So let us see student question number 40. Question number 42. Yes, question number 42. Question number 42 is what? A 4-port. Question number 42 is a cell phone. A cell phone. A cell phone transmit at a power. Okay. A cell phone transmit at a power level of 800 milliwatt. Yes. So this is my cell phone. Yes. So this is my cell phone. Let us say this is my cell phone. Yes. So this is my cell phone. Yes. From here, this is my antenna. This is my what? Antenna. Yes. Cell phone antenna. So this is my antenna cell phone. Yes. From here, power. From here, what? The signal is transmitted from this. Yes. How much power? So this cell phone is transmitting at the power level of how much? At the power level of this is transmitting power. How much? 800 milliwatt. Yes, 800 milliwatt of power. Yes, it is transmitting. So with the antenna gain, how much antenna gain is there? Transmitting gain of antenna is given as 3 dB. How much? 3 dB. Okay. So the cell tower has an antenna gain of, the cell tower is there. So this is my cell tower. Yes. So this is my cell phone. Yes, tower. So you can say this is what? Base station. Yes, cell phone tower. So technical name you know very well for. So this is my transmitting what? This is my transmitting gain. Yes, transmitting gain of an antenna. And this is what? Mobile. Okay, from mobile we are transmitting what? Signal. Yes, this mobile is operating at this power. How much power? 800 milliwatt. This is 0.8 milliwatt. So this is my what? Gain. Transmitting gain of an antenna. Antenna of what? Mobile phone. Yes, this is your mobile phone. And this is what? This is my base station. Yes, base station. So as you know very well, what is this base station is nothing but it's a technical name of cell phone tower. Yes, cell phone tower. So technical name of cell phone tower is nothing but base station. Yes, this base station has an what? Antenna. Yes, this is what? Antenna. Base station has an what? This is what? Antenna of base station. And this antenna has what? This antenna has gain. The gain of this antenna is, this is what? Receiving antenna. The gain is what? How much? 10 dB. This is what? 10 dB. Okay. So this is 10 dB, and this distance is what? This distance is about how much? How much distance is this? 5 kilometer. Yes. This is 5 kilometer distance from my mobile. Yes, from my mobile station to this base station. Yes, base station. This is what? Cell phone tower. So remember that the technical name of this cell phone tower is nothing but base station, and where the signal is received by what? By this cell phone tower. Okay. So the antenna gain of this cell phone tower is what? 10 dB, and receiving power that we don't know. Yes, we don't know about receiving power. How much is receiving power from this? Yes, so this is my transmitting signal from mobile to base station. So now let us say, now further he is saying that the transmission frequency is how much? Transmission frequency here is how much? 600 megahertz. How much? 600 megahertz. Yes, so 600 megahertz. Noise level at the receiver input is, noise level at the receiver input, if you see the noise level at this receiving input is how much? This is minus 95 dBm. How much? dBm. Yes, this is what? 95 dBm. How much? This is what? Noise power. Okay, so noise power at receiving side. Yes, noise power at receiving side is minus 95 dBm. So now transmission frequency is this. Okay, so and required signal to noise ratio to close the link is 5 dB. So link is 5 dB means if we want to close this link, means we want to make perfect signal. Yes, perfect what? Signal link. Perfect signal link from this mobile to base station. Then for that required signal to noise ratio is how much? Sorry. So signal to noise ratio required is how much? 5 dB. 5 dB. Yes. This is what required. This is what required. So then he is asking about find the link margin in dB. So what is link margin? Yes, link margin. So he is asking about link margin. So he is asking about link margin. How much is this link margin? So we have to find this. Okay. So now first of all, this is signal to noise power. So okay. So this is what signal to noise power. Yes, signal to noise ratio. This is what 5 dB. This 5 dB is required for to make the signal link perfect. Perfect. From what? From mobile to base station. Mobile to base station. So this is what link to make the link. This much signal to noise ratio is given. Okay. So what is asking? He is asking link margin. Link margin means how much additional signal to noise ratio is there. How much margin of signal to noise ratio that we can get from this data? From this data. First of all, we want to find what received power. What received power at what? At base station. Okay. At receiving side. How much received power is this? PR is equal to PT GR divided by GR divided by what? 4 pi. What? 4 pi R by lambda. 4 pi R by lambda whole square. Yes, whole square. So this is my received power. Yes, received power. So now see here. See here. If you see, this is what PT. How much PT is there? Transmitting power is 800 milliwatt. I can write this as 0.8. Yes, 0.8 watt into transmitting gain. Transmitting gain of antenna is how much? 3 dB. So this is my 3 dB. Yes, 3 dB. And this receiving gain of antenna is receiving antenna gain is how much? 10 dB. So I can add because in dB gain is always added. Yes, this is 10 dB. Yes, this is my dB. So PTGT. Okay. So divided by what? 4 pi. 4 pi. 4 pi into R is what? Distance. How much? This is my R value. How much is the R? So this is 5 what? Kilometer. So 5 into 10 to the power 3. 10 to the power 3. So now what is lambda? So let us calculate this lambda here. Lambda is equal to C by F. Yes. How much is C? 3 into 10 to the power what? 8 divided by frequency is how much? 600 megahertz. So this is 6 into 10 to the power 8. So it get cancelled. So this is what? Lambda is equal to what? 1 by 2 meter. Yes. Wavelength is what? 0.5 meter. So just put this wavelength here. How much is this? 1 by 2. Total whole square. Yes. How much is this? 0.8 into what? Into this is 13 what? dB. 13 dB. Okay. 13 dB. So divided by this is what? 16 pi square. 16 pi square into this 2 will come up. This is 10. Yes. This is 10. 10 into 10 to the power 3. Yes. So this is whole square. Yes. Whole square. So now see here. So what is this? This is 0.8 into 13 dB. 13 dB means if you want to convert this 13 dB in linear, how much is 13 dB in linear? 13 dB is in linear is nothing but this is 10 to the power 13 by 10 is equal to what? 10 to the power 1.3. Yes, 1.3. So this is nothing but 10 to the power 1 into 10 to the power 0.3. Yes. If you see 10 to the power 0.3 is approximately equal to 2. Yes. So you can write here 10 into what? 2. So this is what? 20. Yes. So you can say that 13 dB. 13 dB is approximately equal to what? 20. Yes. In linear. In linear it is 20. So now you can write here 20. Yes. 20. Divided by how much is this? This is 16. 16 pi square. Pi square value is approximately equal to what? 10. 10. So 16 into 10. 10 into 10 to the power how much? 10 to the power this is 4. 8. 8. Okay. So now see here. So this is what? 8. 16. 16 divided by 16 into 10 to the power 9. Yes. 10 to the power 9. So overall received power is how much? 1 into 10 to the power minus 9 watt. Minus 9 watt. Yes. So means what? We got received power. How much? Received power 1 nanowatt. 1 nanowatt. Yes. So this is my received power. Received power is how much? 1 nanowatt. Yes. This is received power. Means signal power is 1 nanowatt. So now, because here if you see this noise power is given as 95 dBm. This power is given in dBm. Okay, so then let us convert this received power also in dBm. So then we can calculate signal to noise ratio in dBm. Okay, so this is what received power in nanowatt. Okay, so let us convert this received power in dBm. So this is nothing but received power in dBm is nothing but signal power in what? dBm, which is nothing but received. This is nothing but 10 log received power divided by 1 into 10 to the power minus 3. So this power is in dBm. What? dBm. Always remember sorry, always remember when we are going to convert from linear to dBm, always divide that power by 10 to the power minus 3. Okay, so that will get converted into dBm. Okay, so this is my signal power in dBm. How much is this? 10 log. What? 10 log. PR is how much given? 1 into 10 to the power minus 9 divided by 1 into 10 to the power minus 3 dBm. Yes, dBm. So this is what? Signal power. dBm is equal to what? Is equal to 10 log 10 to the power 1 into 10 to the power minus 6 dBm. Okay, so this is what? Signal power dBm. dBm is how much? If you see this minus 60, what? Minus 60 into log 10 dBm. Okay, so how much we got this? So this is my what? Cell phone tower. Always remember this is my cell phone tower. And here how much we got this signal power in dBm? Signal power in dBm we got minus 60 dBm. Yes, minus 60 dBm. This is my signal power. Yes, signal power we got minus 60 dBm. Okay, so now see, this is my signal power in dBm and this is my noise power in dBm. Now we can calculate signal to noise ratio. Yes, we can calculate signal to noise ratio. Let us see here. Signal to noise ratio is how much? Signal to noise ratio is in dB. Okay, so signal to noise ratio in what? In dBm. In dBm is how much? Signal power. Signal power is how much? If you see, this is what? 60. Yes, signal power is minus 60 dBm. Okay, so minus noise power is how much? Minus 95 dBm. Okay, so now see here, this is minus 60 dBm plus this is what? 95 dBm. Yes, 95 dBm, and which is nothing but equal to 35 dBm. Yes, 35 dBm. So this is my signal to noise ratio. Yes, signal to noise ratio in dBm. Okay, dBm. Now see, given is what? 5 dB. So actually it is dBm. Okay, so but the answer and signal power is given in dB. So let us take this as 35 dB. So because actually the answer should be in dBm. Okay, so because everything is coming in with respect to dBm. Okay, so because the noise power is given in dBm. So if we convert this whole expression in dBm, so answer we will get different. Okay, so that's why every term is in dBm, but according to all the option that is given in dB, and signal to noise ratio is in also in dB. So let us take as 35 dB. Okay, so don't do, because if signal is, if the all the option is, some option is in dBm and some option is dB, so you should give the answer according to dB only. Okay, so this is 35 dB. Okay, so now signal to noise ratio is 5 dB. Okay, so how much we got, that is what over total, yes, that is over total signal to noise ratio. Yes, this is my total SNR. Yes, total SNR is equal to what? Total SNR is equal to what? Is equal to SNR required, plus link margin. Yes, plus link margin. How much margin we got? Yes, link margin. So this is required. How much is required to make the between perfect link between what? Between mobile phone and this cell phone tower. Okay, so this is what required. So required is given how much? 5. Yes, how much is it is given as? This is given as 5. So how much required is there? 5. So how much total we are getting? 35. We are getting total 35. Yes, we are getting total 35 dBm, 35 dB, 35 dB. But here required is how much? 5. Yes, how much? 5. And link margin, how much we will get link margin? So this is 5 dB. So okay, so that is, it is understood that everything is in dB only. Everything is in dB. Yes, dB. So everything is in dB. Okay, so this link margin is how much? 35 minus 5. Yes, dB. So how much link margin we got? 30 dB. So this is what? 30 dB. Okay, so this is what? 30 dB. So we got the link margin 30 dB. Okay, so we have calculated receive power, then after that signal to noise ratio, that we got how much? 35 dBm, but required is only 5. How much extra we are getting? 30. So that extra is nothing but over link margin. So therefore the answer is what? Answer is C, 30 dB. Okay, option C is correct. So that is 30 dB. Okay, so 30 dB. So this is set C. Okay, set C, question paper set C. Okay, so 42 answer is C. Okay, so let us move toward next question, 43.